are going to start this course nanotechnology in chemical engineering. So, today we will discuss about the introductions and overview of this particular course. So, nanotechnology that is based on nanoscience and it is an interdisciplinary science. Nanotechnology is the technology of materials that dealing with teeny dimensions from 1 to 100 nanometers. The material changes its property once it changes its size below 100 nanometers. So, using the same materials one can get a range of properties. Thus, nanotechnology needs physical, chemicals and biological as well as engineering and other skills, so that the material and its potential can be applied to many broader applications for betterment of society and humanity. Through this course actually we will learn the basic understanding nanostructure materials, particularly the synthesis of various nanomaterials and their properties, analysis of that techniques and applications of nanomaterials in different field of applications that deal with the chemical engineering. So, the aim of this course is to improve the basic knowledge of nanotechnology for final year undergraduate, graduate students in chemical engineering. This is basically a elective course, and this course primary objective is to enable the students to understand the synthesis, analysis of the methods and applications of various nanomaterials in chemical industry. So, this course will reinforce understanding the basic concept and principles of different industrial applications associated with the nanostructure materials in chemical engineering discipline, such as heat transfer, mass transfer, catalysis, wastewater treatments and renewable energy. So, in the contents we will discuss about the history of the nanoscience. So, from where the nanoscience or nanotechnology has been started. So, that will details or we will discuss the history of that nanoscience, then introductions of nanoscience, nanotechnology, what is nanotechnology and why nanotechnology is important and applications of nanotechnology. So, there are several books available on nanotechnology that is written by leading scientists working in nanotechnology. So, here you can see the syllabus. So, in the first week we will discuss about the introductions of the sections and then nanostructures, nanomaterials, and then we will discuss nanomaterials manufacturing techniques, that is physical methods, chemical methods that we will discuss, and then nanostructure characterizations, nanomaterials characterizations techniques and nanotechnology in heat transfer, mass transfer, catalysis and other various applications that we will discuss. So, here are the list of means references books are available. So, you can study one of these or any one of these which are available. So, based on that we will discuss this course. Okay. So, let us start. So, what is nanotechnology and why it is important? So, suppose if we want to, let us say you want to conduct any reactions or any heat transfer operations, mass transfer operations, any biological applications, then we always go for a materials, that means external materials that sometimes we are using as a catalyst, additives. If we use that materials in the bulk scale, so then that materials will work for that particular reactions or particular systems. But when we change that materials into a smaller scale, so then that property would be little bit different. So, therefore, that materials if we synthesize, particularly the nanoparticles, nanowires, nanofilms, so this type of materials will particularly will synthesize. So, there are so many materials we are using in as a semiconductors, quantum dots, biomacromolecules, self assembling nanostructure materials, nanostructure thin films, nanostructure composite, many materials we are using. So, once we prepare those materials at a particular method of synthesis we will use, after that we will do the characterizations techniques that would be implemented or will be used to characterize that particular materials, and then we will study the various properties of that materials we will synthesize. Then we will discuss about the applications of nanomaterials. So, whatever we will synthesize and that things we will discuss, that is based on or from chemical engineering aspect we will discuss. Okay. So, at the beginnings we will discuss about the history of the nanoscience. So, how the nanoscience has been developed. So, we have smaller and efficient personal computer. Nowadays we are using personal computer, laptop, compact disc, pocket transistor, mobiles, digital camera. So initially at the beginning, that materials or whatever the things we have used, so that was very heavy and bulk size. So day by day that has been changed into lightweight and smaller electronic device. So therefore the scientist has that only is possible because of the scientist has been reduced the size of the materials into the nano dimensions. As a result, overall the system has been reduced its weight as well as size. So if we look into that, so the atoms, whatever the materials we are using, means that may be any metals, aluminum, cobalt, nickel, so or any gaseous atoms or molecules, that in the naked eye it is very difficult to, means in atomic scales that size is 0.03 nanometer to 0.3 nanometer. So that is very small size, so it is very difficult to see those materials in the naked eye. So therefore if we want to identify or detect those materials, so then since those are in nanoscale, so then there is some techniques or analytical means methods are available. So nowadays it is available, so initially it was not available. So day by day with the improvement or with the development of various characterization techniques, that is possible to study or even able to detect such as X-ray crystallographic, electron microscopy methods, many methods are available. So with the help of those we can find out or we can detect those materials in even nanoscales. So almost 15 years back, so when Einstein that predicted say about the existence of atoms, so in 1959 Richard P. Feynman suggested that it could be possible to build a machine for small enough to manufacture object with atomic precisions. So he said that what I want to talk about is the problem of manipulating and controlling things on a small scale. So he described how the enter for example, so one can say that, so or he said that the enter Encyclopedia Britannica, that large volume that could be written on a head of a pin, and how all the books could fit into a few pamphlets. So means initially suppose we have a large scale of books or others materials that is bulk size. So we can make that into a smaller systems or device where we can everything we can put. So that has been actually initially had been begun or started. So 1857 Michael Faraday synthesized stable gold colored nanomaterials. So his gold, whatever the materials he has prepared on that time, that is still it is available in the British Museum in UK, that magenta red color of that solutions. So that was prepared from the gold precursors, and then in that materials on that times it was prepared in the nanoscales, and that beautiful magenta red color solutions that is possible on that times, means it was started on that times. After that 1931 Iruska and Macknall so developed the first electron microscopes, and then in the year 1951 Muller has developed the field ion microscopes for imaging of atom from the tip of the metallic samples. And then on the year 1968 A.Y. Cho and J. Arthur developed molecular beam epitaxy technique for layer by layer growth of materials. So whence we need to develop a materials, means different materials one layer to another layers for a particular applications. So using that molecular beam epitaxy, so that is the possibles to grow that materials. Later an important breakthrough that was developed on the year 1981 by Judd Binning and Heinrich Rohrer in the labs of IBM's lab in Zurich Research Lab, Switzerland. So they have invented or developed scanning tunneling microscope, that is called STM. So by which the atom resolutions can be obtained. Means I said that the atomic size that is less than 1 nanometers in that scale. So that is possible since using this STM microscope, so possible to detect those materials in that molecular or atomic level. Later in on the year 1985, Kurls and Kroto, R.S. Mellers, they have synthesized and discovered 60 atoms carbon molecules, that is called fullerenes, means carbon molecules may have a cage like structure, so that they have developed on that times, and then and after that this type of structure or materials that is called fullerene. So we can see this type of bulky or means cage like structures materials developed and detected on that times. So after that 1986 Gert Binning, Calvin Quete, Christopher Gerber developed the AFM atomic force microscope. So with that microscope on that time they have 1986 developed, and after that 1989 that came into the market. So similarly scientists also developed several instruments such as scanning probe microscopes to collect image, analyze, identify of atoms on a material surface. So here you can see, so on the year 1989, so Donald Igler and Erhard Schweitzer, they displaced 35 xenon atoms onto a crystals of nickels, and they have written on that nickel crystals that IBM that words you can see here. So here's with the help of 35 xenon atoms, so that placed over the crystals of the nickels, and they have by that way or through this study, so they have opened many new doors for the further scientific discovery. So later on the year 1991, S. Ijima discovered the carbon nanotubes. So that was developed since on the years, and the carbon nanotubes that is made of materials of carbons. And then these are the history, brief history or things just have discussed. So after that we are going to get the concept of nanotechnology. So in the introduction, so I said that it is a interdisciplinary science. So it needs physics knowledge, chemistry knowledge, engineering knowledge as well as biological knowledge. So based on that, so this particular course we can study and we can get an idea about this nanotechnology and nanoscience. Okay. So in nanoscience or nanotechnology, to get an idea about the dimension of that materials or within that the things we are going to discuss. So any materials whenever means through this course, so the materials whatever, if it is in the range 1 to 100 nanometers, so that we can see it is a nano range or nanomaterial. So nanomaterials, it is very small dimensions, you can see it into the power minus 9 meters. So that is the nanometer range. So any type of materials whatever, so once its dimension has been changed into smaller, so then its property everything would change, means its mechanical property, thermal property, optical property, many property would change. Therefore if we apply that materials for specific applications, so then that would give a different results that we expect from conventional materials that we are going to use. Okay. So here so this is just to scale, means nanoscales means in what range. So if we go down the dimensions from large to small, so then we can get an idea. So here an examples I am giving. So to get an idea about the things we are going to discuss, means nano means very small. So here's 10 hydrogen atoms, so that has been arranged if we in a line. Okay. So then the dimension or length that would be equal to 1 nanometer. So then 10 hydrogen atoms equivalent to 1 nanometer. So if we think about 1 hydrogen atom, so that equivalents to 0.1 nanometer, so very small. So that actually gives the idea about very small or very small things we are going to means when the materials or the things we will discuss, so that is in that range. So here another image that I am going to show, that is platinum cobalt nano particle composite. So here it is a team image. So you can see here different particles whatever that forms platinum and cobalt composite material particles. So very small scale. So that white dotted you can see, these are the things that has been prepared and that we can see or we can characterize the materials whatever we have developed in that scale. Okay. So another examples, that is muscles of geckos, that is the one kind of lizard. So it has extraordinary ability to adhere to the surface, whatever the surface, that may be plain surface or any smooth surface, a rough surface, anywhere it can hence hold that, and it can move from one point to the another point. So if we notice in nanoscales or in their how they are means moving or sticking with that particular surface, they have actually keratin hairs that is in nanoscales dimensions. So on their feet actually that is cover up that type of hair, so that stick to the surface of the walls, and then they easily can stick to theirs and easily can move from one point to the another points. Okay. So here another examples of nasturtium leaf. So in the leaves in normals, if we see in the macro scale, so that image is like that here. So this is the image in macro scale. So once we go into deeper in the micro and then nano, so then we can see the means once we go from means after gradual magnifications from macro to the nano, so then the surface nanocrystals on that particular surface or that leaf, so that easily we can see once it is means progressive magnifications of that particular substance. Okay. So similar another one's solid metal hydroxides or calcium hydroxide nanoparticles, you can see that is the AC TEM image. So here's same and TEM image. So here you can see that the calcium hydroxide that form the nanoparticles. So once we get that particular image, same or TEM image, so in that particular hexagonal type of materials, those are the forms over the surface. So it can be easily visible, or depending upon that applications we can synthesize, we can apply that materials, and then we get a good results using those materials. Okay. And how this material means, once we changes the materials from one particular bulk size to the smaller or nanoscale, so what type of things are changes in that materials. So let's say here one examples means one particular cube, so that having surface sides, so that is 1 meter, so one cube 1 meter. So if we make or reduce that length of that cube, this particulars means whatever the materials that present over there, so if we make that materials into smaller means if the dimensions, if we gradually change by using particular methods, synthesis method, so then length of that size 1 meter to nanometers it would change. As a result, the number of cubes also will change, means 1 to 10 to the power 27 number of cubes. As a result, initial surface area it was 6 meter squares. So then it the surface area also will change, means if we go from this to this material, so then the surface area suddenly will change or increase, the surface area increase. So here also means to get an idea about the nanoscale. So here's the dimensions of the suns, dimensions of the earth, or height of the Himalayas mountains, height of humans, height of virus, the dimensions, as well as any nanomaterials or nanoparticles we synthesize. So that's dimensions, it is very a small scale. So here's the dimension to gradually are going to down, and the size or dimension is going to down. So this will give an idea about means on which or the nanoscales that materials we are going to discuss, that is very small. So once we apply those means for a particular applications, so mostly it has been means, so we can from chemical engineering point of view, there are a lot of applications, means once these materials we synthesize, so that materials we can apply for any applications, that may be energy applications, catalysis, electronics, domestics, appliances, space and defense, automobiles, sports and toys, textile, cosmetics. Many applications are there. So where a particular means a lot of materials or molecules or compounds, everything we are using in our daily lives, and there's these particular nanomaterials, nanocomposite materials using to make that materials into more efficient, more effective, more efficient materials that we are means day by day needs, and as a result we are getting smaller, lighter materials and effective materials for every applications. Okay. So from application of nanomaterials, here few examples I will show. So here's whatever the means in biological samples, there are also means this nanomaterials, whatever the nanomaterials means metal oxides, CNT, anything, so whatever we are preparing, so that we can use for any biological applications. So depending upon their property, we can means analyze means whether that materials of a particular means drug delivery, or as a that materials is required for that particular means, suppose the materials we are prepared a magnetic material, so that materials is used for that particular purpose. So let's say magnetic materials, when so that would be coupled with a particular binding surface or target molecules. So once we means that materials move to that particular or positions, so then if that materials possess any magnetic properties, So, magnetic vector of that all nanoparticles that is present on that particular surface. So, that would be parallel, and if we have a particular characterization technique, then with the help of that we can get a strong magnetic field or magnetic signals. So, based on that we can say that the materials is present over that particular target place where we are going to see that material. So, based on that magnetic properties of that materials we can detect and we can analyze, we can solve our that particular problems. At the same time, if suppose that materials do not interact with that virus or any means microorganism that is present. So, if that nanomaterials is not interacted with that particular target materials, so then there would not be any magnetic property that would not be aligned. So, with the help of means detections of that particular characterizations, if we do not get any magnetic signal or weak signals if we get, so based on that we can say that that materials does not present or very less amount that material is present. So, there is some biological application. So, by that way we can say that that material whether it is present or not, so that we can detect. So, another examples that is in nanoscale. So, let us say cadmium sulphide. So, CDS that materials we can prepare from any precursor solution. So, once we prepare it, so it has dimensions let us say more than 10 nanometers. So, then it would gives a red color of that materials. So, if we change that dimension of the materials means once depending upon the preparation methods I said. So, if we are able to prepare that materials means wide range we can prepare. So, if we are able to reduce that size of that nanomaterials, let us say initially it was 10 nanometers. So, if we change the dimensions or prepared that materials less than 10 nanometers. Okay. So, CDS particles, this is cadmium sulphide CDS. So, if it is more than 10 nanometers of its dimensions, so then it would give it reddish colors. Once we change the dimensions into smaller, that may be 4 nanometers, 6 nanometers, 4 nanometers, 3 nanometers or 2 nanometers or smaller, as small as possible. So, then its colors or means optical properties that will change, means initially it was red colors, reddish colors. So, then it gradually change into orange colors. So, it was also red, so and then red to orange, and then it moves to yellow, and then it's moved to white color. So, if we change, since see in this particular materials, if we change the dimensions means 10 to 2 nanometers. So, then optical properties means orange, red to orange to yellow to white, that way it changes its property. So, depending upon our applications, so if we prepare and apply this particular materials in a particular applications, so then overall the means where we are applying the system property or material property will change. As a result we will get different results. Okay. So, okay, so today is up to this. So, thank you.